Hello again, it's Noob, and do you know what? I'm so excited to be able to show this off to you. This is one of the sort of coolest, weirdest, and most awesome locks, and technically it is a lock that I have in my collection. And this is the Castell Interlock. So Castell, who make this, obviously make a lot of equipment and locks and isolation devices for industry. You may have heard of them before because of the Castell Interlock, a little lockout tagout lock which would be used to lock out machinery that shouldn't be used or is under service, etc. So don't get confused between the Interlock and the Interlock. The Interlock is so called because these locking mechanisms here all interlock at the back, and I can show you that, and it's kind of cool how this whole thing isn't electronic, it's fully physical locking. It's just so cool. If you work in industry and you work with lots of electronics, dangerous machinery, you might already know what one of these key exchange interlock systems is or is for, but I'm relatively new to this, so if I get any of this wrong, just correct me in the comments. I won't mind, I'm not precious about it. But this is what I understand it does. So all of these are technically locks. You might not believe it, but yeah, they are. And all of these are technically keys. So imagine if I had a piece of, machinery, dangerous machinery, doesn't matter what it is, whether it's, got live electricity going through, it's dangerous to be near, or lots of spinning parts, whatever. You want to keep it behind a cage so that it just keeps people away from that machine, that automated process, so it can just get on with what it's doing without anybody getting in there. So this here would be the key that you would use to go and open up that cage to look at, service, problem, shoot, whatever it is, that piece of machinery. When you're not doing that and you lock the same lock that this key fits into up, you lock the machinery up using that same lock, you then put this key in here like that and turn it. That then locks this in, you can't pull this out. Then you can remove these keys, and you can have, I think, any number of these that your system requires. They're probably custom made. And these will then go and turn on various other devices or power switches or whatever it is. They turn on some machinery. Isolation boxes, various switch boxes, whatever it is. Then finally, you have this master key, if you like, and that would again engage with probably a master on-off switch, which would power on that dangerous machinery you'd locked away in the cage. So what's really cool is that when this key is out and therefore powering up whatever it is, even if you took these ones out, you can't turn them. They have to go in sequence. They will not turn at all. Neither will the red one. You actually need to put the green one in first, turn it. So you've already isolated the equipment. Then you can take out the other keys from the other equipment and interlock those. So what you're doing is you're making doubly sure that there is nothing powering this machine at all. Nothing at all is powering this machine. This is completely off, and only when you've got all your final keys in can you then remove the key, the red key, which will allow you to go service whatever it is that's behind that cage. It's so cool. And same backwards, you can't remove this one until you've gone all the way back through, remove the small keys. Only then can you, take the master key out. Why do I keep calling them keys? Well, it's because each one of these is actually a lock. It's a very basic lock, but it's absolutely a lock. So if you look down here, this whole section here turns. And that core is turning against these pins, which are, if you just look there, ever so slightly tapered, which means they're thicker at the base than the top. I'll explain later when I'm picking this why that's really important and why it makes picking it hard and long. Now, what's interesting is if you look at the key, so there is a 4-pin lock. If you look at the key, all of the keys are flat. So technically the bitting is the same on each key, but this key will not go in here, and this key will not go in here. It will not turn. Well, you know, it just won't go in. You can't swap these keys around. Why? Well, these ones are interchangeable, but this one isn't. Well, it's because they are, well, for want of a better word, warded. There's milling in here that corresponds with the, just caught that, almost dropped the key. Milling in here, which corresponds with the embossed or raised section, which is probably also milled out, on the face of the core here. So if you look here, you've got the, let's call it the mirror image. And only then will that be able to sink deep enough into that keyway to press all of those 4 pins down and turn. So in a way, it doesn't need to have a different bitting on the key. The locking mechanism can just be 4 pins that need to be pushed all the way down to their 0 point, or the shear line, should I say. But what stops it from doing that, and what stops you being able to interchange these keys, is essentially this milled out pattern. It has to match the inside of the key. It's just so weird and well thought out. You might see these in effect a bit like a tubular lock. So this key and this key essentially are pushing down pins in the lock to a shear line, and they turn. I imagine though that these do not have a separate key pin and driver pin. They are literally probably just a pin which needs to be pushed down all the way to the bottom. Nevertheless, it is a rudimentary locking mechanism. These are keys, they are locks, they are essentially a warded tubular lock, if you will, and I just find that whole thing really, really cool. So let's see how this mechanism works. How is it that you can only put that key in first, then this key, and this key before we can release this key? Well, it's all a physical mechanism at the back, and it's so cool to actually see, or at least I think it is. So if you look here at the back, you'll just see that there are interlocking discs. And if I try to turn disc 2 here with the key, even if it's the right key, it won't turn properly because this is actually blocking it. So this here is acting like a cam in a way, and it's actually blocking its progress. So if I put the green key in and turn it, you'll see it frees up a gap, which will allow me then to turn this one, which then frees up a gap, which will then allow me to turn the third one, which frees up a gap, which will allow me to turn the fourth one. There we go. And will eventually allow me to turn the end one back. And then it works all the way backwards like this. So you turn, I've got to get that right, turn that, which means I can turn this, which means I can turn this, which means I can turn this. And then finally, that frees up a gap to be able to turn that little master key there. And we are done. Such a cool little device. Never seen anything quite like it. It's definitely a line of locks, albeit a type of mechanism which is clearly not designed for its high security. Just make sure that you you know, power down things in turn and in the right order and have all the right keys. So it's a safety device rather than a security device, but nevertheless so cool. I love it. Right, let's have a go at picking this. It's yeah, it's an interesting way to pick these, and I won't be picking all of them because it would take forever. But I'm just going to pick, say, one of these locks. They're all the same anyway, as you have found out. But yeah, keep watching. So this is going to be one of the weirdest picking setups that I've got. So I've got a nice it's a Sparrow's High HD, and that's quite sturdy pick, so I can press down on the pins. But the tensioning tool is, well, it's a pair of I forget what we call it. These are vice grips, but obviously, but they're like a curved nose vice grip. And I'm going to. It's quite exhausting picking this as well. Each of these pins, because of its tapering, takes multiple goes to set. So you end up going around and round and round and round and around and around, just picking the lock. But we will have a go. So I'm going to apply tension. So grip and turn. And then get going. By the way, if this takes too long, I will speed this up. So you see, this is binding, so push it down. And I don't know if you saw this turn, but it did turn a little bit. And it's just like picking any of these tubular locks, really. You go along and you pick the pins, in turn as they bind, and also try to keep this like a super vice grip on the vice grips to keep going around and setting these tapered pins. And it is that taper that on the pins which is causing them to set multiple times, because they move a little bit and then the next pin binds, and then when you pick that it'll re-bind one of the other pins which has settled a bit further down on its taper, and you keep going around and around and around, and it's yeah, it takes forever. And we're there. Just turn it a little bit further. Oh my goodness, my hand is like it feels like a claw, just trying to keep constant tension on these bent nose grips is insane. Now what I'm not going to do is overturn it. I shall show you that it's fully picked, that we've gone past the get the light in there for you a bit more, so you can see that we are fully past the corner positions where the pins were. We can turn this with our fingers a little bit left and right, but I'm not going to move it any further across. I don't want the pins to lock up to the next corner, because that isn't actually how far these go anyway. So I'm just going to turn it back, and you'll see the pin set. There you go. And that's where the key would only go that far anyway. It wouldn't go even 90 degrees. It doesn't go 90 degrees, so you only need to move it one pin position along, and you're picked. But wow, that is epic. Now imagine if you were trying to pick that, followed by this, followed by that, followed by that. You'd need hands of steel or a better tool, or maybe something which can actually just press all the 4 pins down at the same time. Let's be honest, it wouldn't be hard to make a tool which was just basically 4 prongs which just turned the whole thing in one go. You could bypass all this warding and stuff. It would be really simple. The pins all just need to be set to the lowest depth. We only picked it, of course, for the fun challenge of picking it, because, well, that's what us lockpickers do. But clearly we do make life a lot more difficult for ourselves than we need to. Well, I hope you enjoyed exploring this superbly odd but very cool lock. Yeah, absolutely love it, and I'll see you all next time.